Hi, everyone. Thank you so much for joining us today. We are really excited to have you here. Today's webinar, Workplace Safety, Ergonomics, Motion Capture, and Future Trends, is being brought to you today by Exons, which is a Movella brand in partnership with the Institute of Industrial and Systems Engineers. Now, in case you aren't familiar with Exons, they are leading the way in 3D motion tracking technology. Exons creates technology that helps track and measure how people and objects they move in the real world. And they make special motion capture systems, which are used in industries like sports, gaming, healthcare to understand body movement, improve performance, and create realistic animations. And today, we're going to explore some key aspects of employee health and well-being, focusing on how effective practices and motion capture can play a huge role in improving workplace safety. Additionally, a few case studies from organizations we all know will be sprinkled throughout the presentation as well. And I am Trent Sexton. I'm with the IISE, and I'll be providing technical support for today's webinar. Before we dive in, let me just go over a few things before I turn the presentation over to today's presenter. During the presentation, there may have some questions that come to mind. So we greatly appreciate your input. If you would, please type that in the chat tab at the top, and we'll make sure to try to get that as quickly as we can. After presentation, there will be a moment for a brief live Q&A, and we can address those questions as time allows. Lastly, the recording of today's webinar will be sent to all registrants via email shortly after we conclude, along with a certificate of attendance. The slide deck and recording will also be available on the webinar's archive page on the IISC website. You can see the link there at the bottom. Here you can also find previous webinars on a variety of topics and to register for upcoming webinars that are all free to attend. We have one coming next week, actually, for how to create a world-class ergo team. This is being brought to you by the Applied Ergonomics Society. So we highly recommend that if you can, please register for that and attend that as well. And like I said, those are free to attend. Since this is an ergonomic-focused webinar, I want to bring to your attention the upcoming 2025 Applied Ergonomics Conference that we host every year. This year it's going to be in Orlando, March 17th through the 20th. Hundreds of like-minded professionals will be in attendance, showcasing their ergonomic solutions through the 2025 Ergo Cup, networking, just learning ways to improve workplace safety and enhance productivity. Movella has actually been an exhibitor at the AEC conference with us the past couple of years. We're grateful for that, and that's how we came to know these guys. And so we hope to see organizations like yours as well. So if you haven't yet, not now, but after the event, the webinar, please check it out at iise.org/AEC. Make sure to register, attend, exhibit. We hope to see you there. Now, I am thrilled to introduce today's presenter for you. Today is Jared Watt. Hey, Jared, how are you doing? Jared has been in the health and sports sector for over 6 years, helping clients tackle some pretty big challenges with motion capture technology. At Exons, he manages client relationships centered on human movement research. Through his deep understanding of motion capture technology and occupational health, Jared helps clients choose and implement solutions that enhance workplace safety and reduce injury risks. Jared graduated from St. Francis Xavier University in Canada, where he also currently resides. And if you would, after today's presentation, make sure to do him a favor and connect with him on LinkedIn. His LinkedIn link is there, and so make sure to do that. And so, Jared, we're very glad to have you here. Thank you for being with us, and I will turn the presentation over to you now.
Thanks again, Trent. I appreciate that. Just to mention the AEC conference, I've actually been lucky enough to attend the last 2 years and can't recommend that enough. It's a great time, lots of learning. So thank you everyone for joining the webinar. Got a great turnout, so that's great to see. And thank you to the IISE for allowing me to speak today. Excited to get things going. So yeah, like Trent said, my name is Jared Watt. Worked with Exons for almost 4 years now within the health and sports business unit. So that encapsulates a lot of different topics, but includes industries like biomechanics, sports science, human movement research, and of course, occupational health and safety, which is why we're here today. Those all blend very nicely together based on, our background in research and, the data that we provide. So little agenda for us today. We're going to talk about occupational health and safety from my perspective, diving into topics like why this is such an important field, the opportunity cost of not implementing a strong health and safety program, tools that I've seen used for assessments. So hopefully you can learn a bit there about what other companies and industries are doing. And where are the different types of motion capture? How can they play a role in occupational health and safety? We'll dive into specific use cases and future trends in the industry. So yeah, hopefully you get some value out of that and seeing what I've seen in the industry. So let's get started. What is occupational safety and why it matters? So I'm sure a lot of you are very familiar with this, but this is, again, kind of my point of view from somebody who has worked with these companies and seen various things over the past 4 years. So why does it matter? So we want to protect employee well-being, minimize risks, and make sure everyone has a safe and healthy work environment. Pain points that I've seen are high injury costs, which we'll dive a little bit deeper into in the next slide. The operational continuity and quality standards, so just ensuring that businesses can run as smooth as possible. Sorry, I'm just going to turn off my notifications here. So the legal and regulatory compliance, so keeping up with the OSHA standards, cost and resource constraints. So making the most of the budgets that are allotted, being creative with your resources, integration with existing processes. So if something has been used for the past decade, ensuring that the new technology fits into that scenario and can provide a seamless workflow. And then the workforce concerns, so keeping employees happy and safe. And yeah, so first thing we'll talk about is what is at stake here. So when it comes to injuries, so Xsense Movella has been dealing with a lot of research in rehabilitation, sports science. So we're really on the ground level of seeing what can be done to mitigate these risks and ultimately help someone move forward, return to the workspace. So disabling workplace injuries costs businesses and societies more than $167 billion per year, which is a very scary number. The average time lost per injury is 8 days. And the average medical cost per injury is $41,000 plus the indirect costs. And the indirect costs are huge. So what we're dealing with there, it gets lost a little bit in what is affecting the business because of an injury to a worker. So we're talking about things like lost productivity. So you're obviously losing the worker, but then you may have to train somebody else for the job, which is now lost time at the supervisor level. So they have to do the training. You have to pay overtime costs for the employees that are filling in that gap in the business. You know, we have lots of levels of the business involved. So administrative costs for managers and HR, potential legal implications. Morale comes down. There's reputation damage as well. So a quick side story. I was visiting a potential customer that was interested in implementing our technology. So I flew down. I get into a cab to go to the facility, and immediately the Uber driver recognizes where we're going because of the address, and immediately starts talking about friends and family who have sustained injuries and back problems and had to stop working early because of what was happening in those facilities. So if you're in a town that is very focused on that specific business. So I come from a small town, so we have, a few manufacturing facilities and people talk. And so I was in town for 15 minutes before I started to hear the implications of not having a proper occupational health and safety program in place. So yeah, with that, you're getting the increased insurance costs. And if you have those injuries, then your insurance is going to start to go up. So this is what I find so fascinating about the occupational health and safety industry. Such huge implications in a role that's kind of looking after this. It's very measurable. So, health and safety managers, supervisors, associates, ergonomists play a huge role in the organization. And that starts at the top and goes all the way down to the bottom. Everybody has an incredibly important role, and the success of these requirements, or the success of these programs require resources. But there's so much that can be done, and the success of the business really can come down to the occupational health and safety teams, which is very fascinating to dive into and see what can be affected at an organizational level. So yeah, benefits of an established occupational health and safety program. So these can be very, very obvious, and I'm sure everybody knows this. But if we can reverse the indirect costs that I just mentioned, so having the ability to make real-time adjustments in the field. So you're lowering injury, direct and indirect costs. So what we want to do is improve satisfaction, productivity, employee retention. This all starts with a good occupational health and safety program. So again, the massive impact on a company depending on this program that are ultimately established by the professionals on the call today. So I'll talk a bit now about how motion capture can play a role in occupational health and safety and where Xsense kind of fits into this picture. So what we'll look at here is some existing ergonomic analysis tools that I've seen in the field. So we have your pen and paper. Very common workflow from what I've gathered in the industry. This is attractive. It can be very cost effective, but can sometimes be subject to human error. So if somebody does an assessment after their 9 a.m. coffee, they're ready to go, versus 4:30 when we're thinking about what we're going to have for dinner that night. So we're looking at the kind of standardized NIOSH, RULA, REVA manual scoring. And then we have AI and video-based technologies. So a lot of these are popping up more and more every year. So if you're attending the AEC conference, you're seeing a lot more of those technologies pop up. And these can be very attractive. They're typically done with a phone camera, and they use artificial intelligence to analyze body postures and assess the safety of a workstation. So this can be an enticing option because the ease of use and repeatability of it. And we're seeing the progress in these technologies every year, it seems. So it's something that we're definitely keeping an eye on. And then we have the motion capture. So this is what us at Xsense do. So this involves a more standardized approach to the assessments. So we're using high levels of precision in biomechanical data to kind of take that subjectivity out of the equation. So we'll dive a little bit deeper into what this motion capture actually means. So there's two real types of motion capture. We have the optical motion capture. So optical motion capture is the use of high definition cameras, usually mounted around a facility. So if we're looking at like a biomechanics lab, they'll have cameras mounted. They'll have a room specifically for that. And with those cameras, they're picking up reflective markers on the subject's body. And with that, you're getting that biomechanical data based on the markers. Just some issues with that, and kind of where our company fits into the equation is the portability of it. So having the freedom to go to other areas outside of that room that have the camera set up. So the next one is the inertial motion capture. And essentially what this is, there's no cameras involved at all. So we use sensors that are attached to the body. So ideally, we want to get these sensors as close to the bone as possible. And that's how we're going to have the most precise data possible. And with those sensors, we're measuring joint angles from the movement itself. So we're capturing this data with an IMU. So I'll explain a little bit about what IMUs are doing behind the scenes. But yeah, these are kind of the two scenarios in which motion capture is going to be used in occupational health and safety. So I will talk high level about IMUs and how we're actually calculating joint angles and things of that nature. So with Xsense, we kind of started out as a research-based company, and validated data is something that's very important to us. So the accuracy of what we're bringing in. So we use very high quality IMUs to produce these results. So what is an IMU? It's essentially, for the purpose of this, it's broken down into three components, really. So we have an accelerometer. So this just measures how quickly something speeds up or slows down in a certain direction. So we can detect changes of movement, like starting, stopping, or shifting directions. And then we have a gyroscope. And this just measures rotational motion and the orientation of each body part. So if we have a sensor on the wrist and we move that way, our algorithms are picking up that we're twisting. And then we have the magnetometer. So this helps us determine the magnetic north, so we know which direction we're facing. So if we have the acceleration, we have the orientation, and then we have the direction, what we can do there is create kind of a biomechanical model of who is wearing the suit. And with algorithms and over 20 years of developing our software, we're calculating joint angles for the entire body. We have center of mass, grasp space, as well as distance traveled. So if you're thinking about this from an ergonomic assessment standpoint, we can look at the validity of data measuring any problematic postures, but we can also look at efficiencies too. So if we're looking at distance traveled, and if somebody's consistently walking around and they're walking 3 miles in the run of their shift, then potentially that's some data that you would like to look at and see how could we minimize this. So yeah, with all these data points, we use thresholds recognized by global ergonomic standards to look at the time spent in these problematic postures. And we can extrapolate that data over an employee's entire shift. So if you want to take a 3-minute recording of, say a repetitive workspace, we can then extrapolate that data over 8, 10, 12 hours and see basically a running clock of how long somebody is in a problematic position. What is the time that they can do that task until they reach the threshold that potentially becomes dangerous for the employee? So the benefits of the IMU-based system, and I talked about it a lot in that last slide, is the science-based reporting. So really what we're getting is highly accurate, validated data based on international standards. So what we've done is compiled the most trusted standards across the industry and use those within the thresholds that we're creating. We have objective data is the big piece. So we're removing any human error that can be involved in an assessment, taking that from subjective to objective data and getting rid of that observer bias that might come into play. Employee satisfaction, so improving morale, getting somebody in the suit, it's a suit that's been used in a ton of different applications that are really fun to talk about in different business units that we have. So we look at the entertainment space. A lot of famous movies and video games have been created with the suit because they're trying to replicate human movement as well as possible. So it can be fun to get somebody in the suit. They can go home and tell their kids that they were in the suit that helped make their favorite video game. Improving productivity, so looking at that graph space, looking at the distance traveled, things like that can be analyzed to help recreate a workspace to make it more efficient. And the quick ROI, so for reducing injury rates, which is hopefully in turn reducing the insurance costs for the company. So now what we'll do is go through some customer cases, some companies that have implemented us, and I'll talk through some of the different ways that it has been implemented in the different industries that this can be applicable to. So the first one is Toyota. So with Toyota, they've rolled us out all over Asia and Europe. And the challenges that they were facing is assembly line workers were operating under high pressure with short task completion time. So they needed to do things quickly. And in turn, what was happening is they're presented with ergonomic risks because, you know, if they have to do everything so fast, employees are experiencing fatigue, which increases the risk of musculoskeletal disorders. So essentially, what we've done is we integrated with their SJT system to digitize and analyze the human movements for them for their ergonomic assessments. So essentially, what we've done is we fit straight into their current program to avoid any huge disruptions in their current workflow. And yeah, so we have a case study on that online if anybody's interested in taking a bit of a deeper dive into it, but very interesting. BMW is another company that has rolled us out globally, and I've been lucky enough to visit a few of the BMW plants and kind of help with the onboarding and implementation of this technology. So what BMW wanted to do is standardize their ergonomics program across the globe. So having the same standards put in place, you know, in their plant in the US with their headquarters in Germany, and having that across the board, the same data that they're using. And the result, they've developed their own comprehensive tool, training each health and safety supervisor, coordinator, on how to use this and how to interpret the data. And what we have is a fast and non-invasive ergonomic assessment in the environment. So essentially what BMW is doing is they're assessing every workstation that they have. And it's typically, you know, a quick assessment, and then they're using that extrapolated data over time. So yeah, that's another one that we have online, and also happy to talk through any of these use cases with anybody interested. The next one, we have RDW. So for those not familiar with this company, it's essentially the Netherlands Vehicle Authority. So what they're doing is making sure that all road transportation in the Netherlands is safe, economically viable, and well regulated. So it includes a lot of inspections on vehicles and making sure things are road safe, and ultimately keeping the country safe. But this specific use case was keeping their employees safe. So they have, you know, a ton of employees that are doing labor-intensive inspections. So anything involving a vehicle, you know, having to get under the vehicle, having to do overhead work. It is opening up employees to these kind of high-risk postures, which impacts the employee's well-being. And there aren't a lot of ways around that, but what you can do is have the best understanding of what's happening for the employees and mitigating that risk. So what they've done with our system is they have assessed these workstations, and that allows them to make decisions based on the well-being of the employee. So this includes like managerial decisions, better strategies for reducing these physical strains, and enhancing employee well-being. Okay, so another company that's probably less known in the US. So this is a company called Colruyt. And it's a massive supermarket logistics company that places a really high importance on advancing their technology. So they really went above and beyond, a supermarket logistics company. They are very focused on getting the latest technology and doing the most that they can for their employees. Um, so again, it's a very similar setup to what we see. They have 24 health and safety advisors for 33,000 employees. So they're dealing with a huge scale of employees. And there's a ton of pieces that go into this. So moving products at the checkout, one arm holding the scanner in the other, packing shelves. The amount of specific movements are kind of endless in this use case. And you can see what they're able to do with our system is look at this in a live view as well. So as you're doing the assessments, you can see in the small photo there, you can see those thresholds in action. So when I'm assessing an employee, I can see the second that they go into one of those risky postures, and then you can adjust from there live. So now we're going to talk about the kind of future of occupational health and safety and the role of motion capture and how it can be implemented in the future and what is the way forward. What are companies doing that are on the innovative edge of this industry? And I'm sure everybody's familiar with exoskeletons, but exoskeletons essentially they play a pivotal role in reducing the strain, whether that is on the back that's supporting you there, whether it's supporting the arms and lifting overhead. Typically used during physically demanding tasks and things that are high risk. So they've identified the need for an exoskeleton due to this. So where motion capture comes into play is the research behind them. So what we're doing to help the development of exoskeletons, it's really getting a baseline of what these workers are going through before they have an exoskeleton. And then as you're building out the exoskeleton, you're validating the success of the exoskeleton based on that initial baseline of the human movement. So ultimately, behind this is a lot of research that requires highly precise human movement data that allows you to really see the effects before and after of the solution. So with that, in our ergonomic software, you also have the ability to check on or off an exoskeleton. So with that functionality, you're able to see, is this worth implementing an exoskeleton? What is that doing to our overall health score for a workplace assessment? Is it worth investing in it? And it's all based on validated data that has been compiled by these exoskeleton companies. Another very interesting use case that we've seen come up, and this is kind of before the workstation assessment. So we have the assessments for the workstation. So after the fact, we're in the facility where we're seeing employees perform their tasks and we're assessing it there. But there's also the opportunity to get ahead of that. So if you are in the process of creating new workstations, if you're expanding your business and you want to map out what these workstations are going to look like before the fact, this is something that you can implement. And essentially what we're seeing on the screen is creating the workspace in a digital environment and having employees or researchers go through with the suit on and perform those tasks in a virtual environment before you even have to build the workstation. So with this, you can think of it two ways. You can think of, we're building this workstation. We want to know if it is going to be ergonomically friendly before, or you can also go through training modules with new employees, so you practice safe procedures such as proper lifting techniques, machine operation protocols, emergency response actions, or like safe navigation in hazardous areas. And with this, you can have real-time feedback in the virtual environment. So, for example, if a worker bends awkwardly while lifting a heavy object, the system will flag it as a potential risk for injury, in which case you can make the proper adjustments to this workstation before it's built, or coach the new employee on what they need to do differently to ensure that they're safe over time. So again, with these kind of assessments, it works the same way as it would if you were in the facility or the plant. So we are assessing the biomechanical data, so all the postures, joint angles, movement patterns, and allowing the instructors to evaluate the worker's performance, as well as post-training reports, so you can go over these after the case. And offer insights into actions or corrective advice to improve those behaviors over time. So yeah, I've seen a lot of use cases where, if somebody's, let's take an example like the automotive industry. If the automotive industry, they're planning years in advance for vehicle production, and of course, there are thousands of parts that go into a single vehicle, and with that there might need to be adjustments to their current workstation. So this gives them the ability to get ahead of that, 3 years in advance, to build out the new vehicle virtually, and then have all of these production tasks performed in a virtual scenario so that they can get ahead of any problems that might come up in the future. And the reason I'm sharing this is just to kind of unlock the potentials that can be accomplished with motion capture. And it really has to do with the relationship we have in the entertainment industry and the health and sports industry. So it's kind of a great combination between the research-backed data and also all of the integrations that we have with these entertainment use cases that allow us to work seamlessly with these other technologies that are doing things in a virtual environment. That is the end of the presentation. So I believe that Trent is going to put a poll, and then we'll get to some questions as well.
Yeah. Okay, Jerry. Appreciate it so much. Let me get the chat pulled up here. See if we can get through a few of these. Had a lot come in today. This was great. Thank you so much.
That's awesome.
Let's see here. Bear with me. It takes a while to get through these. Let's see here. Our first question came in today. It said, how long are motion capture durations? If long, how do you handle drift and how effective is it?
Yeah, it's a good question. So it really depends. It depends on the workstation that you are doing. So there's two different scenarios really. So if you have something that's a repetitive task and 30 seconds and it's done, and then the employee is doing it again, realistically, if you did a recording of 3 of those movements, it should be pretty indicative of what that looks like over time. Whereas if an employee is doing something that takes 30 minutes and then they do it again, you would want to do the full 30-minute. And of course, this depends on the industry, the company, and what the, I guess, preference of the ergonomic department is looking at. But what I would suggest is the full task at least. So if it's a longer task, I would suggest doing the full task. That way you're able to get a full picture of what the postural risks are in that scenario. But yeah, so with the software, you do have the ability to extrapolate that data over time. So again, you're going to want to adjust for what somebody looks like at the start of their shift versus what somebody looks like at the end of their shift. Because, you know, if you're 10 hours into a shift, fatigue starts to set in. You want to take that into account as well.
Sure. Okay. That's good. And then the second part with this was, can you give an example of a standard that you reference to threshold your outcomes?
Yeah, for sure. So we have a ton of different standards that come into play to create these, and they're based on specific pieces of the body, right? So the shoulder, we're going to use a different one than the low back. So what I can do is you see, I can follow up with the specific standards that we're using, but really what we're looking at is the DGUV stoplight. We're looking at the NIOSH lifting equation, but there's numerous. There's probably about 10 that are used in the actual equations, and you're also able to adjust these thresholds. So if there's a specific standard that you would like to see, you can adjust, you know, the shoulder angle to turn red and identify a risk when you get here versus the standard might be here. So it's completely customizable in that sense. So you can use your own judgment to specify that as well.
Okay, good deal. All right, let's see here. We got one more from Nicole. It says, can you provide advice on how to get business leaders to want to invest in this type of data collection?
Yeah. So I think that's a great question. And really what it comes down to for a lot of the business leaders, and depending where you are at in the organization who needs to sign off of it, it's going to be different things that are important to different people. So if you're talking to, you know, a CFO, then it's going to be a return on investment. So what the best way forward for that is, I think, getting the data from your company to see, okay, what is the implication of an injury? What is our specific company? So when I listed the injury data and what kind of costs are implicated from that, that's kind of industry-wide data. It's not going to be specific to one single company, but if you can get your hands on that data and say, okay, if we implement something like this, are we able to reduce, if we reduce our injuries by 10%, what is the return on investment there? And looking at those numbers. So yeah, that's probably the best way to go about it from a return on investment standpoint. But looking at some of the companies that have implemented this and companies that place this importance on safety is another strong way to present it. Yeah, those are a few ways, but yeah, I've seen a few topics on this at AEC as well. So it depends a lot on who you're talking to.
Gotcha. Okay, that sounds good. Let's see here. The question is, the force data manually input after the data collection?
So the force data, it's based on a few equations. So if we're looking at the forces on the spine, that is an equation that we have in our spine model. However, if there is a load that's involved in one of these workstation. So if somebody has to lift a box from their feet to over their head, you're able to manually input the load in real time. So you can choose if it's one hand lifting something up, and essentially when you're doing the recording, you simply click, you know, 4 if it's 4 pounds, and then off or back down to 0 when that is set down, and that will enter that load into the forces on the body. But as far as forces, if you're thinking about it in the sense of the force that it takes to close a door or something like that, or push a button in, you would need an additional technology to get that force data. We are not measuring force directly.
Let's see here. Here's another question. Let's see here.
I will mention this actually, Trent.
Sure.
So we are in the process of working with integrating some of those leading companies that are using, say, force gloves or some really cool technology on measuring those forces. And we're working currently, I think we might have one done, but I don't want to say for sure. Yeah, working on the integration so you're able to see that data side by side so you can analyze both at once.
Okay. See, we've got some good questions coming in. Joshua said, I'm interested in the exoskeleton toggle. Is it assuming a specific make model exo? Not all are the same and they all offer various degrees of resistance.
Yes. Good question. Yeah, it is not just an exoskeleton toggle that takes the average. It's for a specific exoskeleton that has been studied and that used our data to validate. That's how we kind of have that data to provide the accuracy of it. So yeah, it's a specific make and model, and I can certainly find out the specifics on that.
Gotcha. Another question, how do you deal with the interference with the IMU system in the field?
Good question. Yeah. So somebody must know a little bit more about IMUs. So the magnetometer, for everybody else on the call, the magnetometer, which is one of the components that gives us the direction that we're facing. So it's essentially just determining the magnetic north, and that's how we know if we're facing this way or this way. And the interference that comes into play is if you're in a metallic environment, it's going to skew the data in the magnetometer that can be very problematic for collecting this data. However, Xsense and the technology behind it has developed algorithms to create what we call magnetic immunity. So we're able to operate in conditions that no other IMU-based motion capture company can operate in. So I've seen this involved in the middle of a manufacturing facility that's surrounded by metallic objects, picking metal off the ground that should interfere with the data, but it works smooth. We have some very, very smart engineers that figured that out, and that it's a huge differentiator for us.
Okay. Let's see here. We got a couple more questions here. They keep coming in. Is there the capability to combine this system with weights lifted or carried to work out how the various joints are being loaded, specifically the various forces acting on the spine?
Yep, exactly. So that's what we mentioned earlier with the load input. So previously mentioned it, so it might already be answered, but it's very simple. So as you're looking at the live data come through, you can just click in on your keyboard what that load is. So it does involve you having to know what the weight of whatever is being lifted, and then you're toggling it to 5 and then toggling it back to 0 once it is set down.
Let's see here. Ross asks, does the software auto-analyze the data to provide suggested solutions, almost AI type analysis of the results for countermeasures?
Yeah, good question. So to answer it, no, but yes. No, in the sense that you're not going to have a paragraph spit out that says you should increase the height of your workbench by 26 inches to account for this. But what you are going to see is the overall score of the workstation. And then from that, you're going to see very clearly what is the problematic piece here. So you're going to see, okay, when you look at the report, it's going to say, you know, the posture for the low back is in your problematic state. And then what you're able to do is scroll down in the report and do a bit of a deeper dive into when it's happening and why it's happening. So you're able to see a graph and over time and at what point in this task was the most problematic for you. And then you're able to identify where the problem happened and how you can fix it. But there is some interpretation that has to happen on the side of the health and safety employee to mitigate those risks. But we're identifying when and why it happened. So yeah, yes and no.
Gotcha. Okay. All right. Let's see here. Do the calculated joint forces account for the internal muscle forces, which dominate the JCF?
So no, it doesn't account for the muscle forces. However, we do have, because of the background in research and, so a lot of research studies, and we're used in most universities in a research capacity. We do have a direct integration with, it's a list of probably 8, I want to say, EMG sensors. So you are able to look at that muscle activation at the same time. So it's time stamped with the data. So there are ways to look at the muscle activation during these activities with the addition of an EMG sensor. So those possibilities are there. And we have a ton of integrations with different third-party hardwares that might be helpful in getting you to analyze what's important to you. So what I would suggest, if there is, other data that you want to look at, is to consult with me, and we can go through, the list of integrations that we have that might be important to you. Because, like I said, with this research background, a lot of this has come up over the last 20 years, and we have created seamless integrations with a lot of that other technology as well as software. So it's definitely worth inquiring if somebody is using a software now that they like, or they're interested in exploring that, to just reach out to me and see, and we can have a conversation to see if that's something that we currently integrate with, if it's possible. So yeah, that's.
Gotcha. Also, were the ergonomic risk evaluations shown in the presentation done in real time?
So you're right, we do not use photos or videos. So essentially what's happening is we have the sensors on the body, and the sensors are connected to a receiver that's plugged into the laptop. And so that receiver is ingesting the data, and that's going through the algorithms in our software. And within the software, we're creating a biomechanical model. So you're able to see an avatar walk around in real time with the subject, whoever's wearing the suit. As they walk around, you're seeing it move in real time on the screen. So yes, based on that, we have all of the joint angles calculated in the software. With that data, we are able to use the thresholds to create the ergonomic risk assessment. I think that answers the question, but please let me know if further clarification is needed. I'm happy to elaborate or pinpoint one piece to that.
Yeah, what we'll do is we'll have maybe one more question here. Then I want them to ask you how they can reach you, email, LinkedIn, whatever it is. So we'll get maybe one more question here, unless we have others. Let's see here. Will the system calculate the risk reduction if measuring a baseline task in post ergonomic engineering coaching change? For example, can it show the delta between the two of the same task? Can you tag task assessments in certain ways to do this? Yeah.
So the good thing about the software is that's the goal, right? So you want to do those baseline assessments. Say you implement this technology, you want to assess a specific workstation, do that assessment without any adjustments, and then you're going to get a score. And the overall score is an important baseline to look at, especially when you start to do altercations to that specific workstation. And then once you do that after, you're able to see the scores change. So yeah, you're going to get, aside from the specifics of what is problematic in the postures or the movements and the repetitions, you're also going to get a number and a numbered score based on all that data. And then you're able to compare that with the new assessment after you've made some adjustments.
Okay.
I will put my email in the chat. And please feel free to reach out if you have any questions, or you just want to chat, discuss to see if it's something that you are interested in learning more about. Always happy to talk ergonomics, occupational health and safety, any of those fields. It's very helpful for me to learn more. It's a big industry, and it's easy to kind of narrow in and see surface level. So I like speaking to the folks that are actually doing this on a daily basis, and that's really important to me. So please feel free to reach out.
Yeah, that's great. Okay, good deal.
Thank you everybody for coming out. I really appreciate it. Hopefully this was helpful. And yeah, if there's anything you want to do a deep dive in, please let me know.
Yeah, absolutely. All right. Well, thank you, Jerry, for your time, and we hope to see you all at the next ISE event. Take care, everybody.